Hello class. Based from our syllabus, the first chapter for this subject is the study of change. I actually divided this chapter into 3 videos. So for this one, it will be on the introduction to chemistry. So in this presentation, we will define chemistry, discuss its origin, what is scientific method, branches of chemistry, and the role of chemistry to our society, and justify why you have, or should I say, why we have to study chemistry. Now, the first question that we have to answer is, what is chemistry? So, chemistry is a branch of science that deals with the study of the composition, structure, and properties of matter, the changes that matter undergo, and the energy involved in a given change and condition necessary to bring about changes in matter. That is a very lengthy definition of chemistry, but basically, chemistry is a study concerned with the characterization, composition, and transformation of matter. But how did chemistry originated? So during the 1st century AD, alchemy was practiced. Alchemy, by definition, is the occult study of nature practiced in the 1st century AD by Greeks living in northern Egypt. Its practice spread through the Near East and into Europe, where it dominated Western thinking about matter until 16th century. Alchemists were influenced by the Greek idea that matter naturally strives towards perfection, and they searched a lot of ways to change less valued materials into precious ones. The belief of alchemists that matter could be altered magically was very difficult to eliminate way back then. Nevertheless, through centuries of laboratory inquiry, alchemists invented the chemical methods of distillation, percolation, and extraction. And they devised apparatus that chemists still use today, such as the distiller. Alchemists then encouraged the widespread acceptance of observation and experimentation, which replaced the Greek approach of studying nature through reason. Alchemists greatly influenced medical practice in medieval Europe. So 13th century, distillates of roots, herbs, other plant matter have been used as sources of medicines. So that time they had Paracelsus, who was an active alchemist and physician who considered the body to be a chemical system whose balance of substances could be restored by medical treatment. He had a lot of followers way back then, and these followers introduced mineral drugs into 17th century pharmacy. Although many of these drugs were useless and some were harmful, later practitioners employed other mineral substitutes or mineral prescriptions with increased success. So thus began an alliance between medicine and chemistry that thrives until today. For thousands of years, people have developed technological skills to carry out changes in matter. Pottery making, dyeing, and especially metallurgy contributed greatly to human understanding of the properties of materials. Next, during Middle Ages and the Renaissance period, several treatises on metallurgy and geology were written. Books describing how to purify, assay, and coin silver and gold, and how to use balances, furnaces, and crucibles were published and regularly updated. Other writings discussed glass making, pottery, dyes, and even gunpowder. Some of these treatises introduced quantitative measurement, which were the alchemical literature is lacking. Many creations of these artisans, these alchemists, were unsurpassed even today. Yet while their working knowledge of substances were expert, their approach to understanding matter was different from ours. As in earliest times, techniques were discovered and developed by trial and error. The writing shows little interest in exploring why a substance changes or how to predict the behavior of matter. Alchemical influence persisted, however. Understanding was hampered by an incorrect theory about combustion, the process of burning, and this theory was the phlogiston theory. So this theory stated that combustible materials contain phlogiston, an undetectable substance that is released when when material burns. Now let us watch a video that shows what or who influenced the change on how we see matter. Wait.
Matter is a complicated matter. In ancient Greece, Aristotle stated it was made from fire, water, air, and earth. His theory was accepted for 2,000 years. But now we know it's made of more than 100 elements. So how did we change our way to see it? It's 1772, and a Parisian named Antoine Lavoisier is working to improve the gunpowder. And so he studies how combustion works. At that time, people believed that a fire-like fluid called phlogiston was trapped within all matter, and burning meant setting the phlogiston free. That was why after burning, objects weighted less. Working together with his wife Marianne Pulse, he designed a sealed vessel. Taking careful measurements, they put inside phosphorus and combusted it. The weight of the vessel was the same before and after, because nothing had escaped. That was fine. But the matter left inside the vessel after the experiment, it weighted more than it did before. If the phlogiston theory was correct, it should weigh less, unless air wasn't only air. What if air was made of different gases that could join other substances and make them heavier? Lavoisier had heard the experiments of Cavendish, who synthesized water by mixing two different gases he called inflammable air and dephlogisticated air. Lavoisier set himself to confirm Cavendish's findings. He removed the air inside a vessel with a vacuum pump and let both gases flow in. An electric spark ignited the combustion and, voila, water started to form. Lavoisier proved that water was no longer an element, but a compound made of two elements that he named hydrogen and oxygen. That was a revolution. Air, water. The four classic elements were just combinations of brand new elements that should be identified and described separately. Supported by his wife and scientists who believed him, Lavoisier started that search. They identified 55 elements and found a systematic way to name them. He condensed all his work in the first chemistry textbook ever that contained three simple ideas. Phlogiston doesn't exist, that the matter we see is made of elements, and that matter isn't created or destroyed. It merely transforms through chemical reactions. The rest is history.
Okay, so it was Antoine Lavoisier. Sorry for the pronunciation. So this scientist had a huge impact on modern chemistry by proving that there's something wrong with phlogiston theory. So by doing this, his discovery, he gained his title as the father of modern chemistry. Now, you may be fully aware that chemistry is an experimental science, that is, understanding nature through various experiments. If we're going to break down a typical scientist's thought processes, we could organize them into an approach called the scientific method. Okay, this one. So this approach is not a stepwise checklist, take note of that, but rather it is a flexible process of creative thinking and testing aimed at an objective, verifiable discoveries or verifiable discoveries of how nature works. But before we thoroughly discuss scientific method, let us watch this video first, okay? So this video that I will show you is an example of how scientific method is being done. Okay, so that's an example of scientific method being done. Scientific method starts with an observation. So the scientist starts to ask questions about something. It can be either how, what, who, which, why, when, or even where such things happen. At that point, to answer his questions and satisfy his curiosity, collecting of information or data begins. In the video, the person observed that there is a big difference in his plant's heights, and so he wondered what could have caused this. He then started to collect data. He measured the height of each plant and the conditions on where the plants are. And what did he do next? He made hypotheses. Hypothesis is an educated guess, whether derived from actual observation or from a spark of intuition. Hypothesis is an attempt to answer the scientist's questions with an explanation that can be tested. So valid hypotheses need not be correct but testable. Thus, a hypothesis is the reason for performing an experiment. If it turns out to be inconsistent with the experimental results, it must be either revised or discarded. Back to the video, our scientist came up with 3 tests since his hypotheses were: first, it was because of his reading. Second, it was because of the music playing. And third, it was because of the sunlight. He then proceeded to the experiment to prove his hypothesis. After doing the experiments for 30 days, our scientist came up with the results and concluded that it was because of the presence and absence of sunlight that caused the height difference. So that's how scientific method is being done. It is very important, though, to realize that there is no typical scientist and no single method, and that over the years, even luck has played a role in scientific discoveries. Also, you might not notice, but in our daily lives, we're doing scientific method once in a while. Let us now discuss the branches or divisions of chemistry, depending on what aspects it focuses. So the first one is the inorganic chemistry. It is the study of the chemical nature of all elements and compounds, with the exemption of hydrocarbons and hydrocarbon derivatives. Because if it focuses on hydrocarbons and hydrocarbon derivatives, that is already another branch of chemistry, which is organic chemistry. So the third branch of chemistry is the physical chemistry. It is the study of theoretical aspects of the structure and changes of matter. And the fourth one is analytical chemistry. It is the study of all techniques and methods for discovering the identity or the amounts of the constituents in a sample. And the last one, biochemistry. So biochemistry is the study of compounds, chemical reactions, and chemical interactions that takes place in living systems. Basically, it is the combination of biology and chemistry. Let us look at this figure showing an example where the respective branches of chemistry are applied. In inorganic chemistry, it explains how lack of calcium can affect the growth and repair of bones. Organic chemistry's application here is the development of chemicals to control symptoms of asthma. Physical chemistry lies in the study of the factors affecting breathing rates during exercises. Analytical chemistry has something to do with the development of tests to detect chemicals in the blood to show if organs in the body are working properly. Lastly, biochemistry is applied in the study of how energy used for contraction of matter or muscle should I say is produced and stored. So we have defined chemistry and even its branches. Now the next question is, what is the role of chemistry in our society? Okay, almost everything, if not everything, that we do and encounter in our daily lives involve chemistry. Let us consider the typical activity of a student going to school from a chemical point of view. So we're going to consider your activity assuming that you're already going to school. So first, you wake up from the sound of your alarm clock, produced due to the vibrations of the particles in the clock. And then you take a bath to emulsify fatty substances on your skin and hair using soap and shampoo, which are chemically formulated. After taking a bath, some would even use cosmetics before putting on their clothes, which are dyed polymeric fibers. Then put on their synthetic footwear. You then go to the dining area or kitchen to eat a mixture of cereal and milk for breakfast. Bubulol na ako. So, preparing to go to school, you take your books, which are processed cellulose and plastic electronically printed with light and oxygen-resistant inks. Then you ride in a hydrocarbon-fueled vehicle, electrically ignite a synchronized series of controlled gaseous explosions, and then you're off to class. So you see, just your simple activity, though includes complicated principles, before going to school involves a lot of chemistry already. What I'm trying to convey now about the role of chemistry in our society is that chemistry has something to do with the production of the things that we use in our lives. Furthermore, chemistry provides important understanding of our world and how it works. So chemistry helps us understand the nature of materials so that we can make better use of them and then create new ones or improve the existing ones. For example, the evolution of cellular phones. That one. Starting from the bulky with keypad ones to slim touchscreen smartphones. Furthermore, cell phones are made from numerous chemical substances, which are extracted, refined, purified, and assembled using extensive and in-depth understanding of chemical principles. So these things are just some of the roles of chemistry in the society. That is how important chemistry is. Most of you may be studying chemistry not merely out of curiosity, but it is just because it is an essential part of your curriculum. You may be a student in biology, engineering, agriculture, or any other field. But why do you think that with the course you're in still makes you study chemistry? Well, the answer is that chemistry, by its very nature, is said to be the central science. So central science due to its interconnectedness with other disciplines. So this. Chemistry plays a vital role in biology, medicine, material science, environmental science, engineering, and many other fields. For instance, in chemical engineering, it combines principles and empirical findings in order to produce useful substances like those materials needed in the production of cell phones. Yes, chemistry might not be your major, but you'll definitely be needing it in your course. You might one day ask yourself, what are the composition or the properties of the materials that you're going to use? How, why, and when do they undergo change? So, while choosing a material for constructing a bridge or assembling an equipment, or even while studying the palatability of a food product, you're going to use or you're going to be needing chemistry principles. So that's all for the introduction to chemistry, and here are my references, though any websites and especially chemistry books will do. If you have any questions, you can send it to the email shown in the first slide, jeffganiron@mmsu.edu.ph, or you can also send a message to Jessamay Flojo Ganiron via Messenger, or post it in our group. So I also posted an assignment regarding this topic, so kindly see it. Thank you so much for watching, and stay safe.